Now we can discuss one more problem containing less than or equal to constraint. Maximize z equal to 13x1 plus 11x2 subject to the constraints 4x1 plus 5x2 less than or equal to 1500, 5x1 plus 3x2 less than or equal to 1575, x1 plus 2x2 less than or equal to 420, x1 comma x2 greater than or equal to 0. The previous question that having only two constraints, here three constraints plus non-negative constraint. So, we are introducing, first step is introducing, since it is slack variable we introducing, so since it is less than or equal to constraint we introducing slack variables. Slack variables, how many slack variables? 1, 2, 3. So, S1, S2 and S3. Therefore, our objective function become maximize z equal to, since it is maximization function we can write maximize z itself. If it is minimization we need to convert that into maximization function by multiplying with a negative sign. So, maximize z is equal to 13x1 plus 11x2 plus 0s1 plus 0s2 plus 0s3 subject to 4x1 plus 5x2 plus s1 plus 0s2 plus 0s3 equal to 1500. Since we are adding s1 only to this in order to make this inequality into equation, we are adding s1 to the left hand side. The coefficients of s2 and s3 are 0. The second constraint become 5x1 plus 3x2, since there is no s1 in the second, 0 s1 s2 plus 0 s3 equal to 1575. Third one become x1 plus 2x2 plus 0 s1 plus 0 s2 plus s3 equal to 420, and x1 comma x2 comma s1 s2 s3 greater than or equal to 0. This is our new set of linear programming problem. Now we are going to solve this LPP using simplex method. For that we are going to construct the simplex table 1, which having basis x1, x2, s1, s2, b is the constant term, and we need to write cost of base and Cj values here. Okay. So, table 1 we are writing the equation coefficients of this equation here for each constraint. Okay. So, 4, 5, 1, 0, 0, b value 1500. So, I am writing here 4, 5, 1, 0, 0, 1500, 5, 3, 0, 1, 0, 1575, 1, 2, 0, 0, 1, 420. Then what are the basic variable? Which variable having unit vector s1, that is 1 0 0 0 1 0 0 0 1. So, base variables are s1, s2 and s3. Cost of basic variables are 0. Then Cj values we are write it from the maximization z value z function 13, 11, 0, 0, 0. Now we are going to find out a set of Zj values, Zj equal to Cb into each column. So, 0 into 4 plus 0 into 5 plus 0 into 1, 0. 0 into 5 plus 0 into 3 plus 0 into 2. Similarly, complete the Zj values 0, 0, 0, 0, 0. Okay. B value is also 0. Now we are going to find out capital Cj equal to Zj minus small cj. So 0 minus 13 minus 13, 0 minus 11 minus 11, 0 minus 0, 0 minus 0, 0 minus 0. So which is the lowest negative value? Minus 13. So x1 is our incoming variable. We need to find out the outgoing variable by finding ratio. Ratio is found out by b divided by, which is the key column, x1's column. So b divided by x1. 1500 divided by 4, 375. 1575 divided by 5, 315. Then 420 divided by 1, 420. Which is the lowest positive value? 315. So this is the key row. The element which includes in key row and key column, that is 5, which is included in the key column as well as in the key row. So this is our key element. In the next table we need to make this key element as 1, then all other element in that column, that is this 4 and this 1, we need to make these two values as 0 using row transformation. Before that we need to write which is the key column, which is the incoming variable and which is the outgoing variable. So x1 is the incoming variable and s2 is the outgoing variable. S2 is the outgoing variable. Now we are going for the second table, that is simplex table 2 from this table 1. Here basis x1, x2, s1, s2, s3b, cj values and cb values. Basis variable, in the place of s2 which value come? x1 will come there. There is no change of s1 and s3. s1, x1, s3. Okay, these are the new basis value. Then we need to make this 5 as 1. For that what we will need to do? R2 changes to 1 by 5 R2. So we are going to divide the entire row by 5. So our new value will be, here instead of fraction I am using decimal value. You can use either fraction or decimal, whichever is comfortable for you. Okay. So the row value become 1.6, 0, 0.2, 0, 350. Then this value and this value should be 0 because we need to make x1 as a unit vector since x1 comes in the basis. So in order to make R3, this value 0, what we need to do? R3 changes to R3 minus our new R1. So R3 changes to R3 minus new R2. R3 is the previous R3, R2 is the new R2. Okay. So we will get 0, 1.4, 0, minus 0.2, 1, 105. Now we need to make this value also 0. For that what we need to do? R1 changes to R1 minus 4R2. R1 changes to R1 minus 4R2. This is the previous R1. This R1 changes to this R1 minus 4 into R2. So values will be 0, 2.6, 1, minus 0.80240. Then Cj values, there is no change, 13, 11, 0, 0, 0. Cb values are for S1 the value is 0, X1 13, S3 0. Now we are going to find out Zj, 0 into 0 plus 13 into 1 plus 0 into 0. So values 13, 7.8, 0, 2.6, 0. Then capital Cj equal to Zj minus Cj, 13 minus 13, 0, 7.8 minus 11 minus 3.2, 0, 2.6, 0. Again Zj minus Cj there is a negative value. For optimal solution all Zj minus Cj value should be greater than or equal to 0. Here again we got a negative value. So next incoming variable will be x2. Now to find out the outgoing variable we need to find out ratio. Ratio is equal to b divided by x2 column. B divided by values in the x2 column. So 240 divided by 2.6, 315 divided by 0.6, 105 divided by 1.4. So the ratios will be 92.31, 525 and 75. We need to choose the lowest positive value, that is this 75. So this is the outgoing variable, which one? S3. X2 is the incoming variable, and S3 is the outgoing variable. Which is our key element? The element which includes both in key column and key row, that is this 1.4 is the key element. In the next table this should be 1 and all other elements in that column, these two should be 0. So we are going for the next table, simplex table 3. Here also base is x1, x2, s1, s2, s3, b, and cb values and cj values. In the basis, who goes from the base? S3 goes from the base. In that place who comes? X2 will come there. So base is S1, X1, X2. Basic variables are these three. Then we need to make this 1 point for us 1. For that what will we need to do? R2 changes to, R3 changes to R3 divided by 1.4. R3 changes to R3 divided by 1.4. So our third row become 0, 1, 0, minus 0.43, minus 0.143, 0.714 and 75. Next row transformation, these two values should be 0. For that, here the value is 1. I am going to treat the row first row. Okay. So R1 changes to R1 minus, what is the value here? 2.6. R1 minus 2.6 into R3. So transformation is R1 changes to R1 minus 2.6 into R3. So values will be 0, 0, 1, minus 0.43, minus 1.85, 45. And R2 changes to R2 minus 0.6, R3. So value become 1, 0, 0, 0.285, 0.42 and 270. Every time we need to look that if any value comes in the basis, its vector value, its value should be a unit vector in the table. S1 it's a unit vector, x1 unit vector, x2 unit vector. That is the checking point. If it is not come like that, our row transformation become wrong. Okay. So we got that. Next we are going to find out Zj. Before that we need to write the basics. S1 value 0, x1 13, x2 11. Here also 13, 11, 0, 0, 0. Okay, Zj value 0 into 0 plus 13 into 1 plus 11 into 0, 13. 0 into 0 plus 13 into 0 plus 11 into 1, 11. 0 into 1 plus 13 into 0 plus 11 into 0, 0. Similarly, complete the all other Zj values. 2.142, 13.44, 4335. Okay. Then capital Cj equal to Zj minus Cj, 13 minus 13, 0, 11 minus 11, 0, 0 minus 0, 0, 2.14 to 13.45. Since all values are Zj minus Cj greater than or equal to 0, the solution is optimal, and the solution is x1 is equal to 240, x1 equal to 270, x2 is equal to 75, and Z max is equal to 4335. Okay, thank you.